This is part 3 of Unit 2, Lesson 2's notes. We're going to start this part by doing an example problem. This is understanding the derivative graphically. So really seeing what's going on, because this happens on several problems on the AP test. A lot of the practice problems I saw were this way. You have to identify graphs of the derivative based on what is happening in the graph of the function, and vice versa. So we're going to step our way into it with this problem. So we are to use the expression in column 1, state whether the expression represents length or a slope, and then draw the geometric representation of the expression on the graph of f, which is to the right here in our picture. And a blue pencil to represent any length, and a red pencil to represent any slope. Okay, so let's go ahead and fill in the table and come back to the graph as we go. So the first one is f of a. Now f of a is a point, so it's going to represent a length. And what it means, it's the value of the value of f of x at x equals a. So where that is in the graph is right here. Right there. That is 1. That is our f of a right there. Okay, number 2, f of a plus h. So that again is a length, and it represents the value of f of x at x equals a plus h. So that's that distance that we've moved over here, away from a here. This distance that we've moved away from a, so it is also a length. It is represented by this dotted line right here. So we want to make that blue. And somewhat straight would be nice as well. There we go. So that is number 2 right there. Next, number 3 says f of a plus h minus f of a. So we're taking 2 lengths, we're subtracting them, so we are going to get a third length. So this is the difference in y values of f of x between x equals a and x equals a plus h. Okay, next, then we just have h itself. Now we've already talked about in our picture here that that is a distance. It's how far away we've moved away from h, and I kind of already drew that, but let me just go over it again. Here is my h right there. So that's going to be number 4. And I didn't draw number 3, so let me go back and do that too. So number 3 is just going to be this length here, from here where f of a is to where f of a plus h is. So this length here, that's number 3. For some reason I lost my blue for number 2. Okay, and then, so number 4 is also a length. That's the displacement distance, as it's called. On the x-axis. Between our old friend x equals a And our other old friend, x equals a plus h. Okay, next, we have two different y values that are being subtracted, divided by the distance between the x values. So we no longer have a distance. We can't represent as a straight line. So in terms of a length. So what we're going to do is mark this as a slope. So this is the slope of the secant line. Or the average rate of change on this interval, a to a plus h. So now we're going to represent it with a red line, and it's going to show a line through our 2 points. So it's kind of already drawn here for us. It's this line right here. That's number 5. That one. Okay, and now we have number 6. Number 6 is also a slope because we still have the same difference quotient, but now we're taking the limit of it. So this is a slope. And this is now the instantaneous rate of speed. I always forget the A-N-E-O-U-S. Instantaneous rate of speed. At just one point now, x equals a. Okay? You could also say it is the slope of the tangent line. And that's only for x equals a. You could also say it's the derivative. Okay, so that is going to look like this. Okay, this is going to be red, and it's going to kind of look like, whoops, I completely missed that. Let me try that again. I didn't hit the point A, F of A at all. I did it again. All right, this is my last try. There we go. That's better. So this is 6, this line. And then finally, number 7, we have f prime of a, which is just another way of saying the limit of our difference quotient. So this is, of course, a slope. And it is the derivative of f of x at x equals a. You could also just say it's another notation. For the slope of the secant line, tangent line. And so we don't have to draw any more lines because not only is this 6, it's also 7 as well, because it would be the same one. Okay, so that's how you represent it on a graph, what we're looking at. So symbolically, which is what that whole exercise was leading us towards, is you're going to have to go beyond what you already know, and you need to recognize functions, theorems, properties, and try to apply them in ways that you're going to have to break down or deconstruct the operations symbolically. So this is what I'm talking about. So for example 6, each of the following expression represents a derivative of some function, y equals f of x, for some value c. So we're supposed to figure out what the function is and the value of x, or the value of c. Okay, so what you want to kind of recognize here is that we have our difference quotient for our derivative, and we have a square root here. And so we're looking at this formula here. Let me just write it over here on the side. So we're taking our limit as h approaches 0 of f of a plus h minus f of a, and that's all over h. So we're trying to figure out what the a is. So when I look at this one and I see that minus 2 here, okay, that has to be what f of a is. So that means that if I have a plus sign under here, so I added something to h. So what number did I add? So a 4. So how did I get a 4? So you break this down, and so you can say that f of x equals the square root of x plus 2, and that would make c equal to 2. And the way you can see that is f of 2 then would be the square root of 2 plus 2, which is the square root of 4, and that is indeed 2, so that part works out for there. And then if you find f of 2 plus h, what you're going to have is the square root of 2 plus h plus 2, so that gives us the square root of h plus 4, which is the first part. So that works too. So that's what we're doing. We're deconstructing those. So I'll go a little faster after this. So for this one, we obviously are going to have letter B, e to the cosine of something. And it looks like it's probably e to the cosine of x, because then we have pi plus h up there, which would be our a plus h. So our function is going to be f of x equals e to the cosine of x, and that would make our c equal to pi. And just to verify that, I want to check f of pi would be e to the cosine of pi, which would be e to the negative 1, which is what we have here. So that works. And f of pi plus h would be e to the cosine of pi plus h. So that works there. So that one is good. I'm going to do one more, and then I'll let you do the last 3. Okay, so for letter C, it looks like my f of x is going to have a tangent of 2 something because of this 2 right there. So 2 times something. So it looks like that it's going to be x plus just x, because then I can put 2 plus h in for x, and that would make tangent of 4 work out as well. So that would make c equal to 2, because then f of 2 would be tangent of 2 times 2, which is tangent of 4. So this part works. And f of 2 plus h would be tangent of 2 times 2 plus h, which is what we have here. So that works. Okay, so pause the video, try to work out the last 3, and then when you bring the video back up, the answers will be posted for you. Okay, and there are the answers to D, E, and F. If you didn't get those, make sure that you ask in class tomorrow, and this is the end of our video for lesson 3.